Okay, let's have a look. Okay, real quick. So, what I'd like to do today, I want to add something that it might sound like it's going to be harder, but it's easier. When you multiply or divide rational expressions, we looked at how to add and subtract them yesterday. That's a lot harder. This is much easier because remember when we multiply fractions, all we do is multiply straight across. We don't have to get a common denominator. We just multiply straight across. And if we divide a fraction by a fraction, when you divide by a fraction, what do? You don't divide, you by what?
Oh.
You flip and multiply. You multiply by the reciprocal, right? So dividing fractions is also really not a big deal. So let's look at this example here. Much of what we do is the same, but it's just a little bit easier, right? So if we want to find the product of these two fractions, let's take the first one. All we're going to do is we're just going to factor the top and the bottom, just like we've done before, right? Same thing with the second one. Let's take care of this one first. On the top, what do I do first? Can I factor anything out? We always try that first. I can take out a 5. Good. So on the top, I could factor out a 5, leaving behind what?
X squared minus 3.
Okay, and on the bottom, we could factor out
3x cubed.
3x cubed, leaving us with. So how do we know, right? If we factor out a 3x cubed, we're just going to divide each of those terms by 3x cubed to see what is left behind, right? So, Gabe, what do we get? What's 3x to the 4th divided by 3x to the 3rd? Meaning x to the 1, right? Because the 3's cancel, and then x to the 4th divided by x to the 3rd is x to the 4 minus 3, so x to the 1. How about 18x cubed? 18x cubed divided by 3x cubed? 6. Okay, good. We can go one step further with that. We could split this trinomial up on the top. We could factor that further. So we end up with what? 5x. Bottom's done. But what are my magic numbers on top?
X minus 6 and x minus 2.
Okay, good. So we know they're both negative because they have to multiply to a positive and add to a negative. And 6 and 2 would be the numbers that work. Okay? So that's going to be multiplied by this guy. But let's factor the second one. Well, the bottom's already done. That's nice. What does the top end up being? What can I factor out? Dante, what can I factor out of the top? 4, and then what power of x?
2.
X squared. Good. And I always want to take out the sign of the leading coefficient. So if the first term is negative, I'll factor out a negative. Right? So we'll take out a negative 4x squared, leaving us with what? X. And then 16x squared divided by negative 4x squared would just be, we agree, just negative 4. On the bottom, we're done. We already have an x minus 2. So that one was just a one-step problem. We didn't have to do 2 steps. Okay, so now there's 2 things we have to do here. We're just gonna multiply across, which means we can do a lot of cross canceling, which makes this so much easier than adding or subtracting. But before we do that, let's find any values of the domain that have to be restricted, because here's the rule. At any point during the whole process of doing this algebra, if there is a value of x that would make the bottom 0, then that has to be excluded from our answers, right? And so we haven't canceled anything yet, right? So what are the zeros? What are all the zeros of the denominator in both fractions? 0, right? Everybody agree? So we know that x cannot equal 0 because of that factor. What else?
6.
X cannot equal 6 because of that factor, and 2. Everybody agree? Okay. So now we can move on, and when you multiply fractions, you multiply straight across. So what's great about that is we don't even have to think about these as being 2 fractions anymore. We could essentially just extend this this bar, and everything that's on top, those are all factors of the numerator. Everything that's on bottom, those are just factors of the denominator, stuff on the bottom, right? So can we cancel any like factors?
X minus 2.
Okay, so we could cancel, one thing we could do is we could cancel the factor x minus 2, right? That goes away. What else?
X minus 6.
X minus 6 goes away. And then it looks like we can do some more stuff. What about here? I've got a 5x. Let's take a pause there for a second. We've gotten rid of all of those factors, right? So what does that give us? If I multiply across what's left on the top, I've got a monomial there. Monomial meaning just one term, right? It's not plus or minus anything else. Got a monomial factor and another monomial factor. Let's combine those. Just multiply those together. What's 5 times negative 4? Negative 20. So we know we're going to get a negative 20 on the top. X squared times x is x cubed. And then we're left with also an x minus 4. Everybody agree? Okay, on the bottom, we've just got a 3x cubed. Okay, is there anything else I can cancel then? The x cubes, right? Look, I've got an x cubed on top and an x cubed on bottom, and they're factors. They're not being added or subtracted. They're being multiplied, and I can cancel like factors. Remember, this because this is a really common mistake all the way through, even calculus people will do this sometimes. If I have something like this, x plus 2 divided by 2, I cannot cancel those 2's because this 2 is not being multiplied, it's being added or subtracted, right? So that doesn't work. But up here, it does. I can cancel, because they're being multiplied, I can cancel those. And my final answer then just looks like I'm left with a negative 20 times x minus 4 over 3. And you don't have to expand those out. Those are polynomials. It doesn't say you have to write them in, expanded form. Just leave it like that. Look how much easier that looks though, right? Our answer's pretty small. If we had just canceled all this stuff originally before we looked for excluded values, are there any values of x that are excluded in our answer? Are there any x's on the bottom? No. So it looks here like anything is okay, but remember, it's not. Because along the way, there were lots of factors on the bottom that forced us to exclude some x values, right? So later on, what I did on the assignment is I broke those problems into 2 parts. There's 2 parts to the assignment. I think there's like 5 problems or something like that at the beginning, where you're just going to find out what the product is and write out the simplified answer. So the answer to this problem on Moodle is right there. That's it, right? Later on, I gave you some problems on the second part of the assignment where they ask you to do stuff like this, where you don't even have to find what the answer is, but they want you to find out what the domain would be if you were finding this quotient, right? So for the problem we just did, if those were the instructions, then that would have been your answer, right? Okay, you get the idea? Okay, let's look at just one more, and I'm ready to let you work. So what about this one? Okay, this is a quotient. Let's look at one that's a quotient, because there's something that happens here that's a little bit unexpected, and you got to be a little bit careful about this. I want you to be aware of it. So let's go ahead and factor these just like we did before. So let's start off with this guy. Bottom's already factored. What does the top factor into? What's the top factor into? What are my magic numbers have to multiply to 63, right? Positive 63 and add to a negative. So what are the signs going to be, Greg, if they have to multiply to a positive and add to a negative? 2 negatives, yeah, 2 negatives. What numbers would work? Multiply to 63 and add 16. No. 9 and 7, there it is. Okay. So we get this fraction divided by this fraction. So let's go ahead and factor that. What are the magic numbers on the top?
7.
Yeah, so -7, -4. Would you agree?
Yes.
On the bottom, how do we factor the bottom? Abel, what can we do on the bottom to factor that?
On the bottom, we're gonna take away that x.
Take an x out, good, leaving us with,
X minus 5.
good. Okay, so let's start making a list here, right from the beginning. Let's start making a list of all the excluded values that we have to have. We're dividing the yellow fraction by the green fraction. So what are the zeros of the yellow fraction? Because those have to be excluded. The zeros of the denominator of the yellow fraction.
0.
Okay, so x cannot equal 0 because of that, right? What are the zeros of the green fraction?
0.
0, we already got that one. And
5.
5, okay, good. So far, so good. But you already told me that when we divide a fraction, what do we do, Greg, when we divide by a fraction? Instead, we flip, we multiply by the reciprocal, right? So we'll flip and multiply. So we'll rewrite this as, this one stays the same, right? But now we're going to go ahead and multiply by the reciprocal of the green one. So that's going to look like on the top, x times x minus 5, and on the bottom, x minus 7 times x minus 4. Well, what did that do? Now that I flip that one over, I've got a new denominator, right? After I flip. So what do I have to do to my list of excluded values? Got to add some stuff, don't I? Because now we end up with some other values. What else can x not equal?
7.
Because of that. And x cannot equal 4 because of that, right? Okay, and now finally at this point though, I can do some canceling, can't I? I'm not going to write it all out as just one big numerator and one big denominator. Let's just keep in mind that because this is a multiplication sign, we can cross cancel here, right? So what are some things I can cancel?
-7.
Okay, so the x minus 7 cancels, and
The x is on.
the x's cancel. Okay, good. And I think that's it, right? So then we end up with what for our answer? On the top I get, there's an x minus 9 that survived times x minus 5. And on the bottom we just get 2 times x minus 4. Everybody agree? Okay. So for this problem, that's the answer that we're looking for. But if this had been the other instructions where we want to find the domain, that would have been the answer, right? And really they both go together. Okay? Make sense?
Nap time.
Have at it.
Yay.
Yes.
You said have at it, it's on the nap.
No, that's not what I meant. Where?